Hello everyone. Today I'm going to give you the important information on one of the broader DevOps technology, which is named as Terraform. Terraform is basically an infrastructure as a code. I will give you a brief information on this in this video. Please watch my video till end. And if you have any doubts, then please mention it in a comment. Thank you. Hello everyone. Infrastructure as a code is a Terraform. So, Terraform is one of the broader technology of DevOps. So, in this block diagram, I'm going to explain you about how does Terraform work. So, the diagram shows the basic workflow of Terraform and infrastructure as a code. So, Terraform workflow, which includes Terraform configuration file, which is abbreviated as star.tf. So you first write your desired infrastructure in a Terraform configuration file using HCL. So HCL stands for HashiCorp Configuration Language. So this describe files what infrastructures you want rather than manually creating it. So second one is a Terraform core. So the configuration file is processed by Terraform core is which reads the .tf configuration, which determines what resources need to be created, changed, or removed. It also builds an execution plan, which also communicates with appropriate provider. So afterwards, providers, which Terraform uses providers to communicate with external platforms. The diagram shows providers for AWS, Google Cloud Platform, Heroku, and OpenStack. So for example, if your .tf file requests an AWS EC2 instance, Terraform core communicates with the AWS provider, which then communicates with AWS. Then provider, which infrastructure, the provider translates Terraform's instruction into API calls, which can be understood by the target platform. So for example, Terraform, after that AWS provider, then AWS API and EC2 instance. So Terraform can therefore manage its resource across many of the different platforms. So Terraform state file, which also maintains a state file, normally called terraform.tf state. So that state file, which significantly records information about the infrastructure Terraform, which is managing Terraform, uses it to compare the desired configuration and current state. So this comparison helps Terraform determining what changes are required. So overall flow of the Terraform, which contain Terraform core, the Terraform core which containing providers and state file which abbreviated as .tf state. So providers which containing the AWS, GCP, Heroku and OpenStack. So we can simply explain in this way that Terraform works by taking the infrastructure requirements which are defined in TF configuration files. Terraform core processes these files and communicates with the required provider such as AWS or Google Cloud. The provider interacts with the cloud platform APIs to create or modify resources. Terraform maintains a state file to keep track of the infrastructures and uses it to determine what changes are required during subsequent runs. So overall key idea of this which we want Terraform core is decision engine. Then provider is communicator and .tf state is Terraform's record of what exactly exists. So, infrastructure as a code. So, infrastructure as a code is the practice of managing IT infrastructure using configuration files rather than manual interactive configuration tool. So here we can give a declarative as if we tell Terraform in our way, like if we want 6 servers, then Terraform can figure out like how to create it. So version controlled is like we can get track the history of our infrastructure changes, just like we can take application code. So key features which includes cloud agnostic, then immutable infrastructure, then state management, and then modulator. So cloud agnostic, which also unlike cloud formation for AWS only or ARM templates, Azure only, and Terraform works with any cloud providers, for example, Alibaba, Kubernetes, Azure, Google Cloud, and AWS. So immutable infrastructure, which typically Terraform replaces servers rather than changing it, which can reduce configuration drift. Like, for example, whenever servers become inconsistent over time. State management. Then, for state management, Terraform keeps track of your real world resources in a state file, acting as a source of truth. Modulator, like it is a package code into modules to reuse common patterns. For example, standard web server module used by all the teams. So what is the working of a Terraform? So Terraform basically uses a declarative configuration language to define infrastructure, so which can manages resource in a predictable and automated workflow. So it allows teams to provision, update, and delete infrastructure consistently while supporting multiple cloud providers and environment. So this flexibility makes Terraform a widely adopted tool for scalable and reusable infrastructure management. So Terraform also define infrastructure as a code for repeatable and reliable deployments. So provisions, modifications, and destroys resources through an automated workflow. So Terraform supports multi-cloud on-premises and hybrid environments with a single configuration. So it also enhances scalability, reusability, and operational efficiency across industries. So here is architecture of Terraform. So in this way, we can see the architecture. So this architecture working on the user infrastructure as a code. So here first user creates the files containing desired infrastructure. For example, user can create AWS EC2 instance, user can create Azure VM, and user also create a VMware virtual machines. So infrastructure as a code which defines what infrastructure should look like. So it also include the registry. The Terraform registry provide reusable Terraform modules and providers. So developer can obtain a module provider from registry and use it in Terraform configuration. So IAC infrastructure as a code in Terraform Cloud. So it provides centralized information for running Terraform operator rather than requiring everything to be executed locally. So user can interact with Terraform Cloud through API, public UI. For example, they can trigger or monitor Terraforms run through the web UI or API. So another one is state file plus configuration file. So configuration file which describe desired infrastructure, and state file which records Terraform's understanding of infrastructure which it manages. So configuration, for example, like if we want two AWS servers, so what will be current state? I currently have one AWS server, and Terraform will do like create one additional server. So Terraform Cloud, which appropriate communicates with the Terraform provider. So diagram listing an example of AWS, Azure, then VMware, Alibaba Cloud and Salesforce. So the provider act as translator or connector between Terraform and the target platform. So finally, the provider communicates with target platform APIs and create, modifies or deletes the required resources. So we can conclude that user defines infrastructure using Terraform infrastructure as a code. So Terraform configuration can use reusable modules and providers from the Terraform registry. The configuration is managed and executed through Terraform Cloud using its UI or API. Terraform Cloud uses the configuration and set information to determine the required changes, then communicates with appropriate provider such as AWS, Azure, VMware, or Alibaba Cloud. The provider interacts with target platform API and provisions or update the required infrastructure. So first part is the core engine. So this is the binary that we can run on laptop. It reads our configuration file and compares it with the current state of infrastructure to calculate what exactly needs to be done. Then providers, Terraform doesn't know how to talk to AWS or Azure directly. So Terraform uses providers plugin that translate Terraform code into API calls for specific platforms. So for example, AWS provider, Azure provider, Kubernetes provider. So the state file, which also abbreviated as terraform.tfstate. So this is the brain of Terraform, remember. So it maps our code to real world resources. So if you delete resource file from our code, that Terraform looks like the state file to find the ID of real resources and delete it from the cloud. So here one thing we should note that in Teams, this file is stored remotely. For example, in AWS S3 bucket, so everyone works off the same map. So the core elements are as per below. So first one is Terraform CLI. So the Terraform which automates creation and management of infrastructure. So to list of the available commands, Terraform we can run like Terraform, then space hyphen hyphen help. So this command will display all the available commands with most commonly used one listed first. So the primary Terraform commands which including init, validate, plan, apply and destroy. So init commands which prepares directory to run other Terraform commands. Then validate which checks the configuration whether it is valid or invalid. Then plan which shows that what changes to be made to our infrastructure. Then apply which execute the changes to create or modify. Then destroy is to delete the infrastructure that was previously created. Then second part is Terraform language. So Terraform basically uses HashiCorp or configuration language as I earlier explained. So HCL is designed to both easy read by humans and understandable by humans. So making it great fit for DevOps. So infrastructure elements are managed by Terraform are called as resources. So each resource is defined in block like this example for creating AWS VPC, resource AWS VPC and default VPC. CIDR-block is equal to some IP address we can see 172.31.0.0/16. So the tags and name of the example VPC. So this kind of code looks like. So then Terraform provider, like Terraform provider defines the resource type and data sources. Terraform, so which can manage the platform. So it also uses provision, configure, manage cloud services, databases, network. So it can form a single workflow as I earlier explained in the architecture. So the key points, which also includes the bridge between Terraform and infrastructure operations. So defines the resource and data available for management. So it also supports cloud providers, data centers, network devices and databases. It also enables consistent provisioning across multiple environments. Then fourth is important point like Terraform modules. The Terraform modules is a container for a set of related resources which uses specific task and organized and reusable infrastructure code which containing module block which define in a Terraform configuration which includes the following arguments. So first one is a source. The source which specifies location of a module which can be a local path or a URL. So the name is provides a name to reference the module within configuration. Version specifies particular version of module to use. Resources and variables within a module block. Users can define the resources that make up the module along with input and output variables. Input variables allow values to be passed into module when it is called, and output variables allow the module to return values to calling configuration. So nesting modules can be nested, enabling the creation of complex infrastructure architectures using hierarchical structure. So the Terraform provisioners are useful for tasks like copying files or installing software on virtual machines. However, provisioners should be used sparingly as they are introduce complexity and reduce predictability of deployments. Run commands or scripts after resource provisioning, commonly used for file transfer and software setup, which can increase complexity and require elevated permissions. So recommended only when native transform resources cannot achieve the task. Another one is Terraform state. So it allows Terraform to compare current infrastructure with desired state and apply only the necessary changes. While state can be stored locally and remote storage is recommended for T. It can be stored locally, but it is safer when managed locally. Another one is a local state. So by default, Terraform stores the state file locally on the machine when it is executed. So this approach is simple and effective for individuals for small projects. So idea for learning, experimentation and small scale deployments which give faster access since the state file resides on local system. So what are the limitations of local state? So higher risk of accidental deletion or corruption. It is difficult to share safety and across team. So no built-in locking, increasing the chance of concurrent update conflicts. So another one is remote state. So remote state stores the Terraform state file in a shared backend such as AWS S3, Azure Storage or Terraform Cloud. So which enables collaboration through centralized state management, which supports state locking to prevent simultaneous modifications, which improves security with encryption and controlled access. So common remote backends are as follows: AWS S3, so oftenly paired with DynamoDB for state locking, so which also having Terraform Cloud, Azure Blob Storage, and Cloud Google Cloud Storage. So Terraform private module in registry. So it enables teams to manage, reuse, and distribute infrastructure code internally instead of relying on public registries. So by configuring authentication, users can seamlessly reference these modules in Terraform projects. So it stores organization specific modules with controlled access, which requires authentication, for example, access tokens to use the registry. So which allows modules to be referenced via the module block like public ones. So which improves governance, security, and code reusability across teams. So the Terraform commands like Terraform init, so which action initialize the working directory. So what it does is downloads the necessary providers requires for the code. So what it will does is downloads the necessary providers requires for our code. So for example, $Terraform init, which initialize the backend. Second one is that Terraform plan. So the action required is creates an execution plan. So what it does is it's compare our code with current state and shows a preview of what happened. So it will say like if I plan to create three resources and destroy one. So it does not make changes yet. So Terraform apply. So action is execute the changes. So what it does is it reaches out to the cloud API to create or delete resources to match our plan. The command is $terraform apply. So an execution plan has been generated and it is shown. So fourth one is Terraform destroy. So action is tears down everything. So what it does is deletes all resources tracked in the state file. The command is $terraform destroy. Another one is Terraform import. So which imports an existing resource into the Terraform state, it allowing to be managed by Terraform. The command is $terraform import. Then another one is Terraform console, so which opens an interactive console for evaluating expressions in the Terraform configuration. So $terraform console. Then another one is Terraform refresh. So this command updates state of infrastructure to reflect the actual state of resources. So it is useful when we want to ensure that our Terraform state is in sync with actual state of infrastructure. So $terraform refresh is the command. So here it is showing the example of Terraform. So below is the main.tf file, which provides a simple EC2 instances as I have explained in the architecture. So first it will define the provider, then it will define the resource and the syntax as shown here by type name, and the resource is AWS instances and my web server. So here also the one of the tag is included with name DevOps server. So another thing is explaining the syntax HCL. So resource which keywords to define infrastructure. AWS instance, which is type of resource provided by AWS plugin. Then my web server, the internal name of Terraform, which used to track this resource, and arguments which block inside the properties like AMI and instant type. So Terraform versus other infrastructure as a code tools, like infrastructure as a code and tools are essential for automating and managing infrastructure. Terraform is a popular choice, but there are several other tools like that serve similar purposes. So here it is straightforward comparison, which can help us to understand the differences. So first one is Terraform versus AWS cloud formation. So here is a basic comparison. So feature of Terraform and AWS cloud formation. So scope of Terraform is multi-cloud, AWS, Azure, and GCP. So scope of AWS formation is AWS only. Then the language of Terraform is SCL, which is simple, clean, and easy to read. And JSON or YAML can get very verbose and complex. So state of Terraform is managed by user and local or remote. So and the state of AWS formation is managed automatically by AWS. So here is the difference of Terraform versus Ansible. So we can consider it as a comparison table as well. So the feature of Terraforms are like primary use, focus on setting up, managing infrastructure, and the primary use of Ansible is for configuring system and deploying application. The language of Terraform uses SCL for infrastructure definition, and language of Ansible uses YML for defining task. So stability of Terraform automatically ensure resources and created by only if necessary. And stability of Ansible, which requires careful task definition to avoid duplication. So execution of Terraform, which manages infrastructure changes using plans and state, which execute tasks immediately without state tracking. So cloud support of Terraform, which excellent multi-cloud capabilities, and cloud support of Ansible, which uses multi-cloud configuration, so but limited to the system level task. So thank you everyone for listening to this video till end. So if you have any questions, please mention it in comments so that I can easily give the answers.